Welcome to the CEAT Research Seminar Series, Virtual Edition.
Good afternoon, everyone. My name is Chuck Bunting. I'm the Associate Dean of Research here in the College of Engineering, Architecture, and Technology. Thanks for joining us this afternoon for the CEAT Research Seminar Series, the virtual edition. We have two speakers this afternoon. Our first is Dr. Weihua Sheng from Electrical and Computer Engineering. Our second will be Dr. Kurt Rauser, and he'll be presenting at the bottom of the hour. He's from Mechanical and Aerospace Engineering. Just as an FYI, we are recording this afternoon, so be on your best behavior. Dr. Sheng will be presenting first, and I'll give a brief bio, and then I'll turn the floor over to him. Weihua Sheng is an associate professor in the School of Electrical and Computer Engineering here at OSU. He's the director of the Laboratory for Advanced Sensing, Computation, and Control. He received his PhD in Electrical and Computer Engineering from Michigan State University in May of 2002. He obtained his MS and BS degrees in electrical engineering from Zhejiang University, China, in 97 and 1994, respectively. 8 of his publications have won Best Paper or Best Student Paper awards in major international conferences. His current research and interests include social robots, wearable computing, human-robot interaction, and intelligent transportation systems. His research has been supported by the National Science Foundation, Department of Defense, Oklahoma Transportation and the Oklahoma Transportation Center. He's a senior member of the IEEE and serves an associate editor for IEEE Transactions on Automation, Science, and Engineering from 2010 to 2019. Dr. Sheng, it's all yours.
Okay, thank you, Dr. Bunting. Good afternoon, everybody. Thank you for attending my seminar. So today I'm going to give a brief talk about my research, especially in the smart home and the smart robotics for elderly care. And I'm an associate professor in EC department. So this is the outline. I will cover basically 4 things. First, I will talk about the motivation, why we do this research. Second, I will introduce you the Assisi smart home and the Assisi companion robot. And then based on that, we do some research in the area of human behavior understanding and the human well-being assessment. Then I will give the conclusions and some future work. So why we do this research? The main reason is that the elderly population is growing so fast worldwide and also in United States. So here, this chart shows the trend of the growing of elderly population. And you can see by 2050, the number is quite large. So now many old adults, they like to stay in their own homes when they grow old, right? So because there are many reasons. First is living in your own home. In your own home, it's like you have the comfort, right? And you have privacy. And maybe there are other reasons, maybe financial issues. So a lot of people try to stay in their own homes when they age in place. So there are many challenges in independent living. So first, most old adults have some physical health problems, right? Chronic disease. When you are living by yourself, you may have social isolation that may cause mental health issues. And what happens if there is like an emergency situation, right? So if you are really sick or you fall, how do you handle that? Now you can hire some like a home health care service, right? People to do that, to help you. They can come to your home regularly, but that's very expensive, right? So that's why there is a need to develop smart home environments that can promote aging in place through the use of technologies, and that's the goal. So there are some existing technologies on the market already, like a simple device like those lifeline, a push a button, right? So you just push a button if you feel uncomfortable. If you have emergency, you just push the button and you can get help. or you can use wearable devices like this, right? And nowadays we have seen more and more like Amazon, Alexa, the Echo, right? Or Echo Show, or you have the Google Home. So those are smart speakers. But right now they cannot, offer this kind of healthcare service, right? They are smart, but just like answering questions. They're passive listeners. In academia, there are many research efforts going on right now. Here you can see some robots, right? So called pet robots. So they offer the companionship. So if you live by yourself, it's better to have some companion, just like a pet. And also in some universities, they are developing smart homes. So here you can see some examples, right? So we have the Aware Home Research Initiative, Georgia Tech, and the Gator Tech Smart House from University of Florida. So their idea is to equip all kinds of sensors around the home, so you can make the home smart, so you can monitor the old adult. But they're not commercial products yet. So the fundamental challenges, I think, are this. First, how do you monitor old adults living alone in an unintrusive and elder-friendly way? Basically, you need to understand his daily behavior, you need to understand his physical health and also mental health. How do you do that in an unintrusive, elder-friendly way, right? So you say, oh, you can use cameras watching this person 24/7, which is not a good idea, right? You have privacy issues. And the second is how to deliver healthcare to the old adults using technologies, right? So mainly two research challenges. First, monitoring. Second, delivery. So right now we are more focused on the monitoring part. So I will present you some results we have achieved in the first part. So this is called the RISH platform we proposed. So this is just like a concept, right? So we have a smart home. In the smart home, we have old adult wearing a body sensor network. So you can monitor his vital signs, and you can hopefully get an idea how he's doing in terms of the physical health. And also we have a robot here, which can talk to the old adult and can monitor his behavior. Then we also have some distributed sensors. So that makes a smart home. And then we connect the home to the cloud, and at the back end, you have, caregivers, professional caregivers, or family members, those informal caregivers. So we need a cloud service kind of management system to handle all those services. So this is the hardware architecture we proposed. So we, through some previous NSF project, we developed a wearable called Smart Suit to monitor the vital signs. So this is a body sensor network. And you can see we have those kind of respiration belt to measure the respiration rate. We have ECG sensors, we have pulse oximeter. So this is supported by a previous NSF project. And then we have this robot. So this, I would say, is the centerpiece of this project. So this robot is a mobile robot, and we have another version, which is a tabletop robot. So I will discuss that shortly. Then we have experimental infrastructure, which collects those ground truth data, like the location, and also generate those sound simulation, simulated sound data. And then we have this private cloud, which plays as a cloud, so you can manage the services. And this, so this is the caregiver part. So this is the physical test bed, and I asked my student. So together we built this test bed. This is a small apartment mimicking a one-bedroom apartment. And you can see we have a bedroom here, which is here. Then we have a living room, dining room, a kitchen area, and a bathroom. And in the bathroom, we even have a, a toilet here, which is fake. My student, Hado, he made others, fake furnitures, but we also have some real furnitures. You can see a coffee table, we have bookshelf, we have a bed. So this is the environment, and you can see we have motion sensors on the ceiling, so we can get an idea where this person is. And then we have these two robots here. So the main piece is a robot, right? So what kind of robot, what kind of functions are the capabilities the robot should have? So we did some user study. We talked to those healthcare professionals, and we found out there are three major pieces. First, monitoring, understanding how this older adult is doing. Second, intervention, healthcare delivery. And the third is healthcare literacy, including translation, consulting, telehealth, reporting, those kind of services. So right now we mainly focus on this part, the monitoring part, including monitoring activity, mental health, physical health, and the environment. And we have done most of them here. And we are also doing something in this area, like a medication adherence check, cognitive fitness, and even mood management. And at the core, you can see it's a human-machine interfacing, privacy protection, and the learning. Those are the fundamental research issues. So this is the mobile version of the ASCC board, and we use 3D camera. We use motors to create a kind of pan-tilt unit, so the robot can change its view angle. And we have cameras. We have the microphones. So this is a microphone array. We have 4 microphones. I use the PS3i. This from the PlayStation. It's just 15 bucks, but it's a very good microphone array you can use for sound localization, data collection. So the robot is based on the Pioneer 3DX. I purchased this using my startup. Thank Dr. Bunting. This is from the startup, maybe like 13 years ago. So we use a touch screen to create like a face, and this is the microphone. We have camera, and we have some small computers. And this is a tabletop version. We found out that it's kind of dangerous, to put the mobile robot in a home right now. It's not safe. Old adults may be hit by the robot, right? So a tabletop version is safer and cheaper. So this is we call it the ASCC bot, companion robot. It's a tabletop. So it has a body, it has a power base. We have a face here, and we create eyes, mouth too. So you can make all kind of expressions, facial expressions. So also it has a RGB camera, and we have a microphone array on the top. So this is a auditory perception framework. Our idea is, we don't want to use camera to monitor humans' behavior, which is intrusive. So instead we use microphone array. That means using the sound data, right? So the sound data will be collected by the microphone array, and using the microphone array, you can do like sound separation and the sound localization. So you separated the voice and the event sound, and then based on the event sound, you recognize what he's doing, right? And based on the speech, and you can recognize what he's saying. And also we use a human to help the labeling of the data when you train the model. So we create a ASCC sound library. So this library is the event sound library. Typically you will hear in a home environment. So this is the core part, the sound event recognition. So this requires machine learning, AI to do that. So now we found out if just based on the sound, it's harder to get an accurate recognition. So take a look at this example. If I play this sound, what's that? That sounds like water running, right? This is also water running, but can you tell the difference? You cannot, right? And how about this one? It's like eating some cereal, right? So now if you have the context, or he's in the bathroom, yeah, that means this is you are using the the bathroom, right? Or the sink in the bathroom. Or if you hear this, if you know you are in the kitchen, yeah, the water running sound is because you are using the, the tub in the, you are using the kitchen, right? And this is the eating sound when you are, he's sitting at the table, the dinner table, right? Dining table. So that means the context information is very important. If you have that information, then that can help improve the sound recognition accuracy. So that's the whole idea. So we try to use the smart home sensors to help the sound recognition. So we use this called DBM-based model, dynamic Bayesian network-based event recognition. So we take in the human location data, we take in the audio data, and then we use this model to recognize the human activity. So we first recognize the event, then based on event, we recognize action. Based on action, we recognize the activity. So I will not go into the details of this modeling. So how do you get the location data? I mentioned I will use the smart home environment. So we have some sensors on the ceiling, right? So these sensors are basically IR sensors, just like those motion sensors usually you see in homes, right? So these sensors are not very accurate, but they can roughly tell where you are based on, this reading. So it only gives you like high, low, or 1, 0 kind of output. So yeah, he's around here, or he's in the bedroom, or he's on the sofa, like that. So this does not, introduce much privacy concern, right? Because it's like just IO, 1, 0 kind of sensor reading. So then we use some post-processing based on the sound event. We use some dynamic sliding time window kind of approach and some other algorithm to smooth the data and to get the final result. So we did some tests, and you can see we totally used the 44 sounds or 44 sound events, and we got this result, and you can see the accuracy. If we use a context-based approach, it's high, in terms of accuracy. But if you don't use context, it's called context independent. This blue area, you can see the accuracy is much lower. And we also compare with other approach using HMM-based approach, and we found the DBM-based approach is the best. And these are this is the confusion matrix, and you can see the accuracy about 70, right? Sometimes close to 80. So this is a current state of art. So once you know the activities, once you solve this problem, right? You know what he's doing. If there's any emergency, then you can let the robot, do some motion control, and you can move closer to the older adult, and you can ask him what's going on. Then eventually you can report to the caregiver. So here we have some results here. You can see he's doing different activities, and even some anomaly here, like he falls on the floor, and you collect the sound data, and you create a map of this environment, and the robot will navigate to rescue this old adult if he falls. So I have a video here. Maybe the quality is not very good, but it can show you the idea. I just skip this part. So he gets up from the bed in the morning. So this is the activity recognized by the robot. He's brushing the teeth, like the morning hygiene. So this is totally based on the sound and the motion sensor data. You can see the motion sensor on the ceiling, and the microphone is on the robot. So those dynamic outputs are the type of events. So he used the toilet, right? So now he's washing the hands like this. So maybe I should jump. So he will do the cooking, or maybe boiling some water. So the sound even is recognized. So let me jump to the, so now he's eating. Of course, the sound is simulated right now, you know. We use a speaker to play the sound. So the robot will, so he falls, and the robot knows that. So the robot will come to rescue him or ask him some questions. Are you okay, like that? So that's the basic idea. Okay, so the second part is a well-being assessment. You know, we need to conduct some assessment through clinical interviews so that, you know, the doctors or nurses or caregivers will know the health condition of this old adult, right? So the previous, we only recognize activity. Now, how do we monitor the well-being, general well-being? So we have cognitive assessment, fall risk assessment, and the pain rating. So here I can show a
Hi, Kathleen. How you doing?
Good. How are you?
I'm doing well. Thanks for asking.
This is a general, like,
I'd like to ask you some questions about your memory.
Okay.
All right. Listen carefully. I'm going to say 3 words. You say them back after I stop. Ready?
Mm-hmm.
Here they are. Milk, sensible, before. Now repeat those words back to me.
So this is like a memory
Milk,
test.
sensible, and before.
And
Now keep those words in mind.
so you can have
What
other
is the
questions,
counting?
right? So I will not, because of time, I will not play the whole video. So general idea is the doctor will ask the patient those kind of questions. So this is for cognitive orientation assessment, basically check the memory, you know, so you can find some symptom of Alzheimer's disease, those kind of problems, right? So now the question is, can the robot do this? Can the robot replace the doctor, right? So we developed this whole architecture to handle this. So the robot will talk to the old adult, and you have this natural language processing, you have other skills. So we did we implement that, and we did some field tests with some local adults. We involved like 30 local adults, 20 female, 10 male, average age is 73. So you can see here, those are the questions, right? So different category of questions, asking time, spelling, memory check. This is the performance of the robot. So we compare the question between the robot scoring and the human scoring, and we found that they match quite almost perfectly, you know, so very close, right? So more than 95% they match. So this is a video.
Hi there, I am a companion robot developed at Oklahoma State University. I work as an elderly life smart assistant.
So this is a robot
so please
voice.
call me Elsa Robot. This video shows my capabilities of elderly care. Currently, I can provide companionship through verbal conversation, entertainment, fall detection, video call for assistance, and clinical screening interview.
What is the weather?
Right now, it's clear sky and 52 degrees Fahrenheit in Stillwater. The humidity at 34%.
Tell me a quote.
Here is a quote of Francis of Assisi. Make me an instrument of your peace. Where there is hatred, let me sow love. Where there is injury, pardon. Where there is doubt, faith. Where there is despair, hope. Where there is darkness, light. And where there is sadness, joy.
Rock, paper, scissors.
So you can
Great
play
job.
a game.
You defeated me. Play again. Rock, paper, scissors. Nobody won.
Congratulations, you won 3-2. Welcome to the robot-based cognitive evaluation. I am going to ask you some questions. First, I would like to ask you some questions about your memory. Please listen carefully. I will say the name of a person, the address, and city. John Black, 52A, Tulsa. Now repeat the name, address, and city to me 3 times.
John Black, Tulsa.
Please remember this address. Later, I will ask you to repeat it to me again. Now think about time. What time of day is it?
It is 10:15 a.m.
Now think about where you are now. What state are we in?
So
Oklahoma.
this is the
What
cognitive
type of building are
assessment.
you in?
Oklahoma State University Human Sciences Building.
So we can jump
$3 and a pound
to
of hamburger for $4.
0,
Look at these pictures. Click the circle.
So this involves a touch screen.
Pretend this is a clock face. Please use your finger to draw the hour and minute hands at 15 minutes to 5 o'clock.
Yeah, so then you have the health,
Please skip or touch the face that best
the
describes
pain
your current level
rating,
of
and
pain.
to indicate where the pain is from. So this is like the body.
Now, take a look at these images of the body. Touch all areas of the body where you feel pain most often.
Okay, yeah. So that's basically how you can do the clinical assessment, the well-being assessment. So from the test, we learned that interacting with the social robot can really positively impact the mental health and reduce the feeling of fatigue and the negative effect. But also, we found that they like some features of the robot, including the accessibility to information, the facilitation of assistance, and the design simplicity. But they also indicate some things that we should improve, like the verbal recognition, the delay, even the appearance of the robot. So that's the conclusion. So we found out the new technologies are being developed to help old adults living a better life, and the robots can be used definitely. And so our robot can do clinical interview, cognitive assessment, companionship, fall detection. And so the results of user studies show that social robots are accessible by many old adults. And those are the improvements. And I already mentioned, I think the last piece is the privacy may be a big issue we need to address because you are using the microphones, right? So just like Alexa, people complain about the privacy. So we need to improve that. And in the future, I think we are going to fully develop this robotic health assistant for home health care. And we have an ongoing planning grant. And hopefully next year, we are going to submit a full proposal. And then we want to also multiply this and deploy those robots to a larger scale, to like a community. So we are planning a smart community kind of proposal right now. And so this is acknowledgement. This work is supported by several NSF grants, including the National Robotics, Smart Health, and the Future of Work, also Robust Intelligence. And I acknowledge the collaboration from those collaborators, especially Dr. Fan, Dr. Chi-Chen, and Dr. Bishop. And those are my graduate students. And this Erin is a graduate student from Human Science. So actually this next Friday, we are going to have a workshop that involve professional healthcare professionals. And we are going to discuss that next Friday. So if you are interested, you can, if you want to join the workshop, you can send me an email. I can send you the Zoom link. So that will be next Friday. Okay, any questions?
All right, very good. Well, thank you very much, Wei-Hua, for your presentation. I'm the only one clapping, but emotionally, everyone's joining me virtually and sending appreciation for you taking the time to visit with us today. The paper is open, the talk is open for questions. So please, if you don't mind, unmute your video or turn your cameras on. I see JD's there. Hey, JD, good to see you as always. But I do have a question while we're waiting for others to kind of queue up theirs. You mentioned privacy, and that was going to be one of my questions, and you've addressed that. How do you measure acceptance of the home health robot?
Acceptance. I think we can use like a user, study. You can do a questionnaire, right? So after or before the test, we can conduct like a pre-test survey, then we can conduct a post-test survey. So that I think is a basic technique to study users' response to this kind of robot technologies. I don't know if there are any other better ways to do that. You just ask them their opinion about this robot, right?
Well, glad you have partnering with human sciences. I imagine they would be pretty helpful in assessing things.
Yeah, yeah, they know much better.
Engineers like, well, they didn't destroy it, so they must like it, right? I mean,
yeah, they know how to do human studies. You know how to use statistical tools to analyze the humans, response.
very good. Other questions for the paper?
So, can you hear me?
Yes.
Yeah, my name is Joseph Nuama. I'm a new professor at the Industrial and Systems Engineering Department. And my research, in fact, is in human factors. So I'm kind of very much interested in your research. And mine is to quantify physiological and behavioral states of humans as they interact with systems like yours and others, right? So I probably would get in touch with you by email so that we can talk. But I also do healthcare stuff as well. I had a postdoc at the School of Medicine at UNC Chapel Hill, and basically I was into measuring the physiological states of clinicians as they interact with EHRs and to know their fatigue states and stuff like that. My question really borders on user study and user acceptance studies and how you can access the acceptability, for example, of your system. And did you conduct any user studies at all? And if you did, what were the results? Are there any publications as far as that is concerned?
Yes. We had some joint publication with Dr. Bishop from Human Science, and maybe I can send you some papers. Like I mentioned, we did a field study involving actually totally we had conducted the test on 60 old adults, and that provides sufficient data for analyzing the users acceptance.
Okay.
We conduct here. I just present 30, but actually later we had more tests.
Okay, sounds good. But I'll get in touch. And probably come over to your lab to see what you do.
Sure.
That is something of interest to me. Thanks a lot.
Thank you.
Very good. Well, Joseph, thank you for joining in and asking your question. It's great to see when folks are collaborating like that.